level, but in the examination they are asking this type of question. Okay, so you cannot avoid this topic. Earlier this topic was not very important for net examination, but now in the last 3 years I have seen that there are a lot of questions directly from this particular topic. So we have to revise our +2 level. So mainly we will just revise different type of with different type of problems actually, because I think everybody know what is Newton's law of motion, but we will give focus on mainly Newton's law in a polar coordinate. That is very important. So every year one question is always from Newton's law in polar coordinate. But before that, let's straightforward go to the Newton's 3 law. So what is the Newton's first law? Is the law of inertia. Newton's first law is nothing but what? Law of inertia. So what is law of inertia? Law of inertia will tell you that particle will remain in a same state unless and until you are not imposing some external forces. Okay. So particle will remain in a same state. So what is meaning of that state?
अगर वो मोशन में है तो मोशन में रहेगा, और अगर वो स्टेडी है तो स्टेडी रहेगा
Okay.
जब तक हम फोर्स
नहीं लगा, बिल्कुल सही बात है, बट मैं थोड़ा और डीपली इसको एनालाइज करना चाहता हूँ. If I am saying same state, what is meaning of that? Meaning of what is classical state? The classical state of a system is position and momentum. Okay, so in general, so you cannot change the state of a system unless until you will not apply some external forces. And what is inertia? What is inertia in general? What is inertia? What is inertia?
It's a virtue through which it resists the change of state of motion, state of
Okay.
rest, state
Okay.
of motion.
So inertia is all about resistance to change. Okay. It is all about resistance to change. So you can use this word frequently in your daily life. You are just asking your friend, yeah, you have very high level of inertia. उठते ही नहीं हो, है ना? चलते ही नहीं हो. Are you getting my point? So inertia is all about the resistance to change. आप जिस state में हो उसी state में रहना चाहते हो. So that is all about inertia. So how you will physically measure the inertia of a system? How you will physically measure the inertia of a system?
So by calculating mass.
Mass, exactly. So if I am talking about inertia, I am actually talking about the mass of a system. So if you are calculating the mass, then that means you are talking about the inertia of a system. So this is very important, very interesting, that this is your inertia, law of inertia. That means you are just considering what is the mass of a mass involved in a system. And also you know that rotational inertia, that is moment of inertia, that is all about the inertia used for the rotation. But this is that the linear inertia, that means linear inertia is just a mass. But when you are talking about the rotation, that entirely new type of symmetry will come into picture, and that thing is nothing but what? Your moment of inertia tensor. So right now I am just talking about the linear motion. So why we have talked about the mass of a system, and this mass is nothing. Here we are talking about the point mass of a system. Okay, so this is our consideration, that this is nothing but the point mass of a system. Now this is my first law, very interesting law, very important law. It's a very useful in nature, and always you will see whenever you have first law, second law, third law, then each and everything is connected to each other. Okay, you cannot say this is my first law. The first law is all about the law of inertia. What is your second law? If you are talking about second law, what is this particular second law?
So the rate of change of momentum is directly proportional to the force applied.
Exactly. So you are just talking about
direction also, it is said in that law.
Sorry?
Direction is also said, direction of force.
Yes. So that is all about the F is equal to ma. Isn't it?
Yes, sir.
This is your second law. If you are the rate of change, and A is nothing but rate of change of velocity, and this ma is nothing but the rate of change of momentum. So you can just write something like this also. Rate of change of momentum is directly equal to the force. I can see this whole thing in a very different way. What is my perspective? My perspective is that this is a very famous philosophical expression of cause and effect. Unless you don't have cause, you cannot see the effect. Okay. So this is the cause. And this will tell you all about the effect on a system. So you are just giving the cause from the external world. I'm not talking about the internal forces, because internal forces is not useful in the Newton's law of motion. They are actually balancing to each other, and almost the overall effect is zero. So what we are talking about? We are talking about that F is equal to ma. That means if you are going to give the external forces, some external forces F, and that will be equal to dp upon dt. If you will give some cause, then you will surely see some effect, and that cause must be some sufficient. That should be some in sufficient nature. So if you have cause, you cannot have acceleration unless until you don't have force, isn't it? You will have acceleration if there is some force, there is some external force, and that external force is some unbalanced external force. Okay, so this is very interesting. So this is all about external force. Okay, so this is your second law. So if you are talking about second law, you can think in this way, that there is an effect if there is a cause, or if there is a cause, then there is certainly some effect. And we can measure this thing with the help of one beautiful differential equation that is very famously known as what? Equation of motion. And that is nothing but the Newton's law of motion, isn't it? Okay, now the third and the last is very interesting. What is this thing? पता है आपको? बताइए.
Reaction, reaction.
Action reaction.
Action.
So for every action, so if you have 1, 2 is equal to minus F to 1. So this is very interesting. For every action, there is a reaction, and action and reaction will act on two different bodies. This is very important. Okay. For every action, there is reaction. For every action, there is reaction, and action and reaction will act on two different bodies. So this is our three law, and we have to use all these three law to solve some fundamental problems, some basic problems. So the whole idea of today's class is that we can identify some important external forces, and then we will apply the Newton's law with the help of a very beautiful concept of free body diagram. So we will discuss which type of forces we have to encounter, and then we will just go for how to go for free body diagram. And I am 100% sure that you all people have done in your +2. Okay. But yes, we will revise it such that we can solve some beautiful problems. Okay. So let's try to go for next is, so we will just discuss some 2 and 3 type of forces. Okay. And mainly we have 3 type of forces, you can say. One is pulling effect, another is pushing effect, and one is all about friction, which is self-adjusting in nature. Okay. So we will just try to see what is nature of all these forces. Okay. So if you can categorize all the forces, the first force is very interesting and very important. That is what? Gravitation. Okay. The first force is very important. That is what? Gravitational force. So obviously gravitational force or weight, that is very important in the mechanics, basically weight, and that will be always in vertical in nature. Please don't confuse with x-axis and y-axis. It will always vertical. Okay. So what you will do, you can just take your copy, make it in vertical position, and keep your chalk. It will always go in vertical direction. Okay. So this is always in unidirectional. This will not depend what is your x-axis, what is your y-axis. That will always in vertical in nature. Okay. For example, suppose there is a mass, there is a weight, that will be something like this. Suppose this mass is on some vase, then also weight is your vertical. Okay, even if this mass is there is maybe you are just pushing it, and that weight is vertical in nature. So you can see this is always vertical in nature, always. Okay, always. Even you are on some curve. Okay, let's say this, you are on some curvy nature, and here is your particle, and this is your center. The weight is something vertical in nature. Okay, are you getting my point, everyone?
Yes, sir.
है ना? So आपको
Yes, sir.
कंफ्यूज होने की जरूरत नहीं है. This is just vertical. So you make your copy, see how your pen is falling on your copy. That is the direction of gravity. So this is the thing that you can talk about the gravitational force. Okay. Now, next we are going to, so next two type of forces are there. One will tell you all about the pulling effect, and another will tell you all about the pushing effect. Okay. So what is your pulling effect? The pulling effect can be represented by the tension. Okay. This is all about your pulling effect. You have to pull something or you have to push something. So this will tell you all about the pulling and pushing effect. Okay. So what you have, suppose you have one mass and there is another mass, and you are just pulling with some force F. And these two mass, let's say this mass is M1, this mass is M2. Then you are pulling this particular mass M2. Then on this particular tension, what will happen? In this particular string, the tension will develop. And when the tension will develop, what will happen? This tension will pull this particle, as well as this tension will pull this particle also. What is the meaning of that? Meaning of that, if I am talking about M1, the tension will be act something like in this direction. This will just pull it. And for the M2, you have to be very much careful. The tension will be in this direction. Are you getting my point? है ना?
सर एक बार प्लीज M2 वाला बता दीजिए
देखो,
M1
समझ देखने की कोशिश करो. पुल, आर यू गेटिंग माय पॉइंट? पुल का मतलब क्या? उसको
sir.
खींचना, है ना? इसको भी खींचो. किधर खींचोगे? लेफ्ट या राइट?
राइट
ऐसे ऐसे तो पुश हो जाएगा ना? आर यू गेटिंग माय पॉइंट?
यस सर
तो क्या करोगे? दिस वन. क्लियर है ये? नहीं, फिर से समझो. एक स्ट्रिंग लो, इसके किसी भी पार्ट को खींचो, देन यू हैव दिस फोर्स, दिस फोर्स. अब तो ठीक है?
यस सर
ठीक. उसके बगल में एक और छोटा सा मास लो, तो ये भी ऐसे होगा, ऐसे होगा. अब तो ठीक है? तो
Yes,
क्या
sir.
होगा? ये दोनों एक दूसरे को कैंसिल करते जाएंगे, अगल बगल वाले, है ना?
यस सर
तो लास्ट में है तो उसमें तो एक ही डायरेक्शन बचेगा.
यस सर
लास्ट वाला जो है उसमें तो एक ही डायरेक्शन बचेगा ना?
यस सर दैट विल
और
बी
और इधर वाले का भी एक ही डायरेक्शन बचेगा. ओके,
यस यस सर
अब क्लियर हो गया?
यस सर नाउ इट्स क्लियर
नाउ इट्स क्लियर. सो यू हैव ऑलवेज पुलिंग इफेक्ट. पुल कर रहे हो आप, देख रहे हो, यू आर जस्ट पुलिंग इट. यू आर जस्ट पुलिंग इट. आपको इससे आसान लग रहा है, इसको तो पुल कर रहे हो इस तरफ, इसको भी तो पुल करोगे, ऐसे करोगे तो सिकुड़ जाएगा ना। आर यू गेटिंग माई पॉइंट? you have to give tension on the string, so this is just a pulling effect. ओके ये इसलिए होता है कि बीच वाले सारे एक दूसरे को कैंसिल कर देते हैं और लास्ट वाले जो पार्टिकल हैं जो बंधे हुए हैं वो आपको जस्ट अपोजिट डायरेक्शन में नजर आएंगे, इसमें इधर होगा तो इसमें इधर होगा। आर यू गेटिंग माई पॉइंट? ठीक है, जैसे अगर 3
sir.
पार्टिकल हो,
Yes.
सपोज 3 पार्टिकल हो, नाउ ये मान लो m1 है, ये मान लो m2 है, दिस वन इज m3, इसको मैं इस डायरेक्शन में खींचता हूं। ओके अगर मैं इसे खींचूंगा तो ये स्ट्रिंग भी खींचेगा, ये स्ट्रिंग भी खींचेगा। नाउ दीज टू आर डिफरेंट स्ट्रिंग, सो बोथ हैव डिफरेंट टेंशन। यहां पर तो सेम स्ट्रिंग है इसलिए से दोनों पर क्या होगा, सेम टेंशन। तो इसके ऊपर टेंशन लेट से T1 डेवलप हो रहा है, इसके ऊपर टेंशन T2 डेवलप हो रहा है। नाउ दिस हाउ दिस टेंशन विल एक्ट ऑन M1, बताओ राइट या लेफ्ट?
Right.
राइट,
Right.
वेरी गुड। हाउ दिस टेंशन विल एक्ट ऑन M2, राइट और लेफ्ट?
Left.
So left.
लेफ्ट, वेरी गुड वेरी गुड। M1 M2, ओके। नाउ चलो अब इसके ऊपर फिर से देखते हैं, और ये तो T1 हो गया, T1 T1, और ये T2 भी तो खींचेगा इस पर, किधर, लेफ्ट या राइट?
Right.
Sir, right.
राइट, वेरी गुड। T1 या T2 अलग होगा, T2,
T2.
वेरी गुड। अब M3 पर देखो, M3 का क्या होगा,
Sir,
लेफ्ट और राइट?
The left
Left.
was the tension,
लेफ्ट,
right was
T1 और T2?
T1, sir.
T2.
T2.
T2, वेरी गुड। क्लियर है ये? इसमें टेंशन
Yes, sir.
T1 डेवलप हुआ, इसमें टेंशन T2 डेवलप हुआ। नाउ इट्स क्लियर, ठीक है?
Yes, sir, it's clear.
इट्स क्लियर, वेरी गुड। सो नाउ दिस इज योर पुलिंग इफेक्ट। और पुलिंग इफेक्ट को हम किससे दिखाते हैं, टेंशन के थ्रू। इसका सबका नाम दे दिया है, पुल करना, जैसे पुल कर रहे हो, है ना, यू ऑलवेज पुल समथिंग। सो उसको हम लोग ने फिजिक्स में एक नाम दे दिया है, उसको हम किसके थ्रू दिखाते हैं, दैट विल बी टेंशन। ओके ओके, लेट्स गो फॉर अनदर। हाँ बताओ, कुछ पूछना है? एवरीथिंग इज ओके?
Yes, sir.
Sir,
हाँ बोलो।
the left direction की force, it is due to the mass inertia, right, sir?
No, no, no. That not any force is due to inertia. You are pulling this force with force F,
Yes, sir.
and hence these two particles are attached to the string. Okay.
Yes, sir.
So the effect of this force on the string is that there is development of tension. Are you getting my point?
Yes, sir.
Okay. Now, if there is development of tension, my question is that how this tension T1 and T2 will act on mass M1 and act on mass M2. Are you getting my point?
Sir, force is to the right, so tension should be along the right side only.
No, no. Force is right. And there is development of tension on this particular string. That is T2. There is development of tension on this particular string, that is T1. And now how this T1 will act on M1? So it will pull in this direction. Are you getting my point?
Okay, sir.
And for M2, T2 will also pull, T1 will also pull. Because it is pulling effect. Are you getting my point?
Sir, I didn't get why T1 is pulling in left direction.
Here. This one.
No.
For
T1.
M3. For M3.
M2 T1, sir.
M2. This one.
Oh.
Listen. You can take the string. Okay. अभी तो यही बताया था. You can take the string. And here is end. Here is end. Okay. Take any segment of a string. Tension means tearing. You are tearing it here, tearing it here. Are you comfortable?
Oh, yes, sir.
Okay. Now again you will take another thing. Tearing, tearing. Okay.
Yes, sir.
What will happen? This one and this one will cancel to each other.
Okay.
Okay. In the last, you have only one thing can be there because there is not any another part of a string.
Yes, sir.
So there will be unbalanced string tension is here and unbalanced tension is here. Are you getting my point?
Yes, sir.
नहीं समझ में आया?
समझ आ गया.
देखो खींचना, टेंशन का मतलब क्या होता है? खींचना, पुल करना. So how you will pull it? This will also pull it and this will also pull it. So how you will pull it? What
By
will be, what will be direction of arrow if you are pulling it? M2.
M2 pulling means in the direction of force.
No, no, no. That is not in direction of force. You are just leave this force. Okay? Leave this force. You have nothing to do with this force.
Okay, sir.
Are you getting my point? This force is acting on M3 only. Okay?
Okay, sir.
So this force is acting on M3. So due to this force, there is tension into this string. There is tension into this string. Up to this, you understand all the thing?
Yes, sir.
Yes. Now, what is meaning of tension? Tension will always have pulling effect. Are you getting my point?
Okay.
Okay. So if it has pulling effect, then how you will pull it? Your arrow will be away or towards?
Pulling means
Away.
okay.
Pulling means away, na?
Yes, sir. Yes, sir.
You are just pulling it. That's it. Are you getting my point?
Yes, sir.
So this is pulling. Just
Okay.
take one rope and pull it. Are you getting my point? So both have to be away.
Okay, sir. Okay,
Okay.
sir.
So this is the tension. Okay.
Tension will be always opposite to the mass, away from the mass.
No, no, away. What is mass is not away. Tension will always have pulling effect. It will always pull.
Okay.
Okay. Tension will always have pulling effect. It is always pull. How you will pull it? How this string will pull? Just like this, na?
Yes, sir.
And how this string will pull? Just like this.
Yes, sir.
So it has always pulling effect. If you will will have arrow in this direction, that means you have pushing effect. Are you getting my point?
Yes, sir. Got it. Got it. Thank you.
Okay. Okay. Now this is your pulling effect. Okay. So +2 में ठीक से पढ़ा नहीं था, है ना?
So tension depend on the mass of particle or not?
No, no.
Okay.
It will depend on nature of a string.
Okay,
Okay.
sir.
Okay.
Yeah.
And in general, if a string is massless, ideal string, your tension will be uniform. Okay. Otherwise, it may be dependent on length and mass also. Mass of rope or mass of a string. Are you getting my point?
मतलब it depend on the mass of rope or the string.
A
It
string.
don't depend on the object.
मास पर कुछ भी डिपेंड नहीं करेगा. रोप के मास के ऊपर डिपेंड कर सकता है.
Object के mass पे नहीं depend
कुछ
करेगा.
नहीं, रोप के मास पर डिपेंड करेगा. Okay.
And on the force ना sir, that is applied on the object.
Obviously that force and mass, वो तो अंत में इक्वेशन ऑफ मोशन से ही सारा चीज आएगा निकल कर.
हाँ जी. Okay.
है ना? बट
Thank you, sir.
टेंशन के डायरेक्शन और यूनिफॉर्मिटी पर कोई फर्क इफेक्ट नहीं पड़ेगा. ओके.
Okay.
क्या आप फोर्स लगा रहे हो उस पर तो निश्चित रूप से डिपेंड करे कितना टेंशन लग रहा है. ओके. आर यू गेटिंग माय पॉइंट?
Yes, sir.
But nature of tension will be depend on basically it is uniform or not uniform. That will depend on mass of or nature of rope. Otherwise, it will depend on mass. If you have lower mass, then tension is lower. If you have heavier mass, then tension is heavier. Are you getting my point?
Yes,
Are you getting
sir.
my point? मेरा कहने
Yeah.
का मतलब है कि
Sir,
आप
like what
एक-
I am getting like when we have discussed
Listen,
about
listen,
the type of
listen,
motion,
listen.
ना?
Suppose here you have one string, okay, and here you have mass mg. Are you getting my point? And there is another same string, but you have different mass. Let's say this mass is 2m, and this mass is 2mg, and this mass is mg. Then what will happen? The tension will be same or different?
Different.
Different. The tension will be different. So here is tension T, here is that will be tension different. That may be
2T.
2T. Okay? Are you getting my point?
Yes, sir.
है ना? तो ऑब्वियसली मास और फोर्स के ऊपर तो डिपेंड करेगा ही करेगा, बिकॉज फाइनली यू हैव टू राइट द इक्वेशन ऑफ मोशन। आर गेटिंग माय पॉइंट?
मतलब ऑब्जेक्ट के मास पे डिपेंड कर रहा है जो वर्टिकल में है।
वर्टिकल में तो कर ही रहा है ना, इस पर जो फोर्स लगा उसी का तो रिएक्शन टेंशन में दिख रहा है आपको। ओके,
वेट पे कर रहा है ना, वेट इज
वेट
फोर्स।
पे ऑब्वियसली वेट भी तो एक फोर्स है। आप यहाँ पर एफ फोर्स लगा दो, यहाँ पर 2F फोर्स लगा दो। आर यू गेटिंग माय पॉइंट? देन ऑब्वियसली इट हैज टेंशन T, इट हैज टेंशन 2T।
या मतलब टेंशन एक टाइप से वो थर्ड लॉ ऑफ मोशन की वजह से अपोजिट डायरेक्शन में लगने वाला एक बैलेंस्ड फोर्स है।
बिल्कुल 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 आप कह सकते हो। ठीक है।
Tension force is opposite to gravitation force.
Tension is opposite. Yes, if you will hang it, it will opposite to gravitation force, obviously.
Okay, sir.
Okay, but I am talking about if you have the horizontal force, then
Linear force.
it may be also possible, है ना? Suppose
sir.
ऐसा है, you have F, then this tension is, let's say T. Again, the same mass is there. You have 2F, the same string is there, then it will be 2T. Are you getting my point? M1, M2, same M1, same M2, then it will be T2, it will be 2T. Are you getting my point?
Yes, sir.
But in this, all this assumption, what is the assumption? Assumption is that this string is basically massless. Are you getting my point? ये जो string है, ये string क्या है? ये massless है, ideal string की बात कर रहे हैं। Okay?
ओके सर।
ओके,
सर अगर आप सर एक न्यूमेरिकल के साथ करवाएंगे ना, देन वी विल गेट इट मोर।
ये न्यूमेरिकल ही है, ये न्यूमेरिकल ये। ओके, चलो ठीक है। ओके,
जैसे M1 M2 की वैल्यू लेके और टेंशन T फाइंड आउट कर लेना। M
चलो and next force is what? Pushing force. ओके, पुश करने वाला फोर्स है ना? सो उसको आप सम टाइम रिएक्शनरी फोर्स भी कहते हो, नॉर्मल फोर्स भी कहते हो, समथिंग लाइक दैट। सो व्हाट विल हैपन व्हेन आई एम पुशिंग इट with some force F? Are you getting my point? I am pushing it with some force F. Let's say this is M1, this is M2. Then this F will push M1, then M1 will push M2. And same time from the Newton's third law, M2 will also push M1. Okay? So what will happen? For M1, the pushing force is something like this. This force is pushed by M2 to M1. So let's say this force is, let's say, N. And the same time, this is for M1. What will happen to M2? In which direction?
Right one.
Right one. Right one. Something like this. This will be for M2. So F will push to M1 and M1 will push to M2. M1 will push to M2 and same time M2 will push to M1. So that will be the same thing. For example, you can take it another, let's take 3 mass. So you have M1, M2, M3. You are pushing it something like this. Let's say you are pushing it with some force F. So what will happen? M1 will push to M2 and M2 will push to M1. It has pushing effect. This F will be like this, M1. Okay, N1. And this M1 is also pushing to M2. So this will be N1. This M3 will also pushing to M2, but this will be different force. That will be N2. And this M, yes.
सर फर्स्ट वाले फिगर में जो दोनों M1 M2 पे फोर्स लग रहा है N और N दोनों सेम होगा या डिफरेंट होगा?
ये वाला
हाँ,
obviously same होगा. What is Newton's third law? For every action there is reaction.
हाँ.
And action and reaction will act on two different bodies. They have
Yes.
equal magnitude. So if
Okay.
you are saying this is action, this will be reaction. Action is on M1, reaction is on M2.
Okay.
Equal and opposite reaction. For every action, there is equal and opposite reaction. जैसे यहाँ देख लो, अगर इसे तुम एक्शन कहते हो तो इसे आप रिएक्शन कहोगे, isn't it? एक्शन अगर M1 पर है तो रिएक्शन किसके ऊपर है? M2 के ऊपर, है ना? And similarly, what will happen to M3? बताओ क्या होगा M3 पर?
N2.
N2 किधर, right या left?
Right
side. So that value is M2. Okay. और अगर आप combined रूप से देखोगे, अगर आप suppose M1, M2, M3 को combined way में देख रहे हो, then what will happen? This can be act as an internal force. नहीं? Are you getting my point? अगर आप M1, M2, M3 को सिस्टम मानकर कंबाइंड वे में देख रहे हो तो क्या हो रहा है? ये इंटरनल फोर्स की तरह नहीं बिहेव कर रहा है क्या?
Yes, sir.
Yes. This will cancel to this one. This will cancel to this one. Isn't it? So it will depends on you how you are just visualizing the system. Are you seeing the complete system together? Or you are seeing the individual system together. If you are seeing the individual particle at a time, that means they are acting as an external force. This is acting as an external force. This is acting as an external force. But if you are watching the complete system, then this normal force can be treated as what? As your internal forces. Same thing can be happen for tension also. Look at here. Suppose you have F, this is your M1, this is your M2, this is your M3. So here is like this, here is like this, here you have like this, here you have like this. Let's say this is tension, T1, this is T2. If you are visualizing this M1, M2 and M3 in a combined way, that means what will happen? This will cancel to this one, this will cancel to this one, and this can be act as your internal forces. So here, your external forces, if you are watching that compare the all three body at a time, that is M1 plus, because this F is pulling M1, M2 and M3 together. So this kind of thing is there. But if you are watching M1, then only T1 is there. If you are watching M2, T1 is there, T2 is there. If you are watching M3, then only T1 is there. Are you getting my point? So these all things we will use as a trick to solve the problem in a very efficient manner. Clear है ये?
Sir?
Hmm.
So the motion will happen only when which force will be the strongest?
Obviously, this force will, if these all are frictionless, then this force will act on these three body, and all these three body will move with the same acceleration.
Okay.
Okay, because if it will move x distance, this will also move x distance, this will also move x distance. So all will be moved with the same acceleration. Okay.
Okay.
And then only you can say these things can be act as internal forces. So what you can write? You can directly write F is equal to M1 plus M2 plus M3 into A. In this case also, and in this case also you can write F is equal to M1 plus M2 plus M3 into A. Are you getting my point?
Yes, sir.
But if you are writing for M1, then what will be your equation? F minus N1 is equal to M1A. Are you getting my point?
Yes, sir.
And what about M2? What about M2? N2 minus N1 is equal to M2A. What about N3? What about M3?
Minus M2 equals M3A.
Very good. N2 is equal to M3A. That's it. Are you getting my point?
Yes, sir.
And similarly, here you can also write all this thing. What about your M2, M1?
Sir,
हाँ,
sir,
बताओ.
second one is N1 minus M2
N1 minus
equals to
M2.
M2A.
Yes, sir.
N1
no.
minus M2.
Second one is?
N1
No.
minus M2.
This whole thing is moving in this direction, na?
So N1 minus N2. For M2, N1 is in rightward.
Arey yaar, no. This N2 is always greater than N1, na? Sorry, N1 minus N2.
N2.
Yes,
Sir.
N1 minus N2. Exactly.
Yes, sir. Because
N1
it
minus
will be the
N2.
greater force. Sir.
Yes.
Yeah.
N1 minus N2. Surely. And similarly, we can write it the same thing here also. T1 is equal to M1A. And what about the second one?
Sir, T2 minus
T1
T1
minus
is equals
T2
to
minus T1
T1
is equal to
MA.
M2A. What about third one?
Sir,
F
F is
minus
F
equal to
minus T2 is equal to M3A.
M3.
So this is
M3A.
the equation of motion, second law for the individual M1, M2 and M3. But if we are talking about the combined system, we have neglected all this tension, isn't it? And you can see, if you will add it, then what will happen? This T1 and this T1 will cancel, this T2 and this T2 will cancel, you will get this thing, isn't it?
Yes, sir.
If you are going to add it, then this T2 is cancelled, this T1 is cancelled, you are getting this thing. Similarly, if you are getting to add all this thing, this N1 and this N1 is cancelled, this N2 and this N2 is cancelled, you will get exactly this thing. Are you getting my point?
Sir,
हाँ बताओ.
I have small doubt, sir. In the whole system, internal forces are acted, and the individual system, external forces are acting. How, sir? How you will say?
What I am saying, if you are seeing the whole system, that means these two are cancel each other. So why it is behaving like a internal forces. Are you getting my point?
Okay.
Okay, but if you are talking about the individual particle, then it is not going to cancel each other. Are you getting my point?
Yes, sir.
So why it is just behaving like external. And now you can see, I have also proved there. You can add this one to this one to this one. You are getting this one, isn't it? So effect
Yes,
of
sir.
N1, N2 and N3 will be lost, isn't it?
Yes, sir.
If you are writing this thing, what is meaning of that? Meaning of that, you are adding this one, and this one. And if you are writing this thing, you are adding this one, and this one. So what will happen? These all things cancel out to each other, na?
Yes, sir. Yes,
So
sir.
why? The effect of tension is not there. The effect of normal is not there. Are you getting my point?
Yes, sir.
Okay.
Thank you, sir.
सर हेलो सर सर हम जब डायरेक्शन लिख रहे हैं ना तो यही कन्वेंशन यूज कर रहे हैं ना कि पॉजिटिव एक्स एक्सिस मतलब राइटवर्ड होगा तो पॉजिटिव और लेफ्टवर्ड
नहीं ऐसा कुछ नहीं दे रहे हैं. जिस डायरेक्शन में मोशन हो रहा है उसको पॉजिटिव कर रहे हैं. दैट्स इट.
ओके
है ना?
Okay, sir.
लेफ्ट और राइट वर्ड से कोई पॉजिटिव नेगेटिव नहीं होता है. अदरवाइज यू कैन टेक एनीथिंग पॉजिटिव, बट हमेशा उसी को पॉजिटिव लो. ओके.
हाँ
ये दूसरी बात है कि आपका एक्सेलरेशन नेगेटिव उल्टा आ जाएगा तो आपको उल्टा डायरेक्शन में मूव कर रहा है. आर यू गेटिंग माय पॉइंट? यू कैन आर्बिट्रली चूज दिस इज माय पॉजिटिव, दिस इज माय नेगेटिव, बट उस डायरेक्शन के चीज को हमेशा पॉजिटिव लो. बट वी हैव सम कॉमन सेंस. सो इफ हैव सम कॉमन सेंस वी विल टेक in that direction where motion is going to occur, we are taking it positive direction.
यस सर गॉट इट
Okay, so two forces are very important. One is pulling and one other is pushing. And for that, you need some external forces. Either you have to pull or you have to push. Okay, but the most important force is nothing but the frictional force. Okay, and the frictional force is sometime pushing force, sometime pulling force, depends on its nature, which type of system we are working with. And now you can just go for a very interesting force and very complicated force also. And this is basically what? frictional force. So there is two type of frictional force. Okay, two type of frictional force. First is static friction. And second is kinetic friction. So when your external force, so first we have to know about the limiting force. Okay, what is your limiting force? So there are two type of coefficient of friction. One is mu s and another is mu k. Mu s is static coefficient and mu k is kinetic coefficient, and you will always find mu s is always greater than mu k, है ना? So you can see, आप अगर किसी भी अलमीरा को पुश करो, then initially you have to, जब तक वो move नहीं कर रहा, you have to give more force, and as it will just start moving, you have to give the little less force than that, isn't it? ऐसा feel किया या नहीं? है ना? So this is due to fact that mu s is greater than mu k. So what is your limiting force? Obviously, if your applied force F applied in the direction of motion, actually, okay, F applied in a direction of motion, because friction force is in general try to oppose the relative motion between surface and a particle. Okay, so what is frictional force? It will try to oppose, frictional force will oppose the relative motion between particle and surface. Frictional force will oppose the relative motion between particle and surface. So what is limiting force? So F applied in a direction of motion, okay? F applied in a direction of motion. So you have to just see that which force is providing the motion to the system. So F applied is less than mu s into normal. And what is this normal? Normal to the surface. N is normal to the surface. Okay, N is normal. So if F applied is less than or equal to mu Sn, then you will go for a static friction. And what is limiting friction? The limiting friction is equal to mu s into n. And if F applied is less than mu Sn, then you will apply the static friction. And what is this static friction? The static friction is equal to applied force. Are you getting my point? अभी एक प्रॉब्लम करेंगे तो उससे आपको बेटर समझ में आएगा, है ना? Fs is all about the applied force. When you are going to apply some force and you will find that your applied force is less than mu s into n, mu s into n is the limiting friction, then your frictional force is equal to what? Applied force, and that is your static friction. Okay, so then you will go for what? Static friction. And what will happen when F applied is greater than mu s into n? Then you will go for kinetic friction. And your kinetic friction is always same and that value is mu k into n. Everyone is comfortable?
Yes, sir.
So
ठीक
that
है?
is not equal to F applied, na?
Huh? No, that is not equal to F applied. Frictional force, the kinetic friction is mu k into n. That is constant, always in constant in nature. Okay?
But Fs is changing.
If it is
Sir,
changing,
Fs static friction is
if changing to kinetic friction.
static. No, sir. The value of static friction may change.
Value of a static
Up to a
friction will
certain
depend on what is your applied force.
So
Okay.
it may change up to a certain limit.
Up to a certain limit. So when you are
may
going
change.
to plot frictional force versus applied force, okay, then what will happen? It will go up to some limit and suddenly it will decrease and it will constant. Okay, this is the reason. This region is what? Fs. And what about this region? Is Fk. Okay, so Fk is always constant. This is your constant value. Normal force will always same. Nu k is always same. But here you can see the frictional force is increasing as you are increasing the F applied. Why there is sudden drop after going to one particular limit? You can see
then the friction
because you have that mu s is greater than mu k. Okay, so this is your basically frictional force. Everyone is going to understand this concept?
Sir,
yes, sir.
हाँ बताओ.
Sir,
does that mean that if we increase force if applied also, kinetic friction remains always same?
Always same. Yes.
So even if we increase force,
Yes.
kinetic friction won't increase.
Not increase. Kinetic friction is always constant in nature, ideally. Okay? Okay.
Static friction. will
Static
increase-
friction is self-adjusting
Okay, it will increase up to the point. Then
up to the limiting friction. Okay?
then it will overcome it and it will go to
Yes.
kinetic friction.
Kinetic friction. So what is limiting friction? This is limiting friction. Okay?
Okay.
This is your limiting
Sir?
friction. हाँ.
The coefficient of जो हमारे पास क्या बोलते हैं जो लिमिटिक और जो स्टैटिक का है वो सेम रहेगा?
नहीं अलग होगा ना.
coefficient
यहाँ तो देखो ना mu s and mu k है ना. यहाँ तो लिख दिया ना.
सर जो स्टैटिक और जो लिमिटिंग का है
हाँ.
static और
स्टैटिक
limiting।
का फिर से समझ लो. Limiting friction is mu s into n, nothing to do with mu k.
Okay,
Are you getting my point?
जी सर।
That is mu s into n.
Yes.
Are you clear?
Yes. सर जब लेस वैल्यू होगी तो हमारा वो स्टैटिक, जब
हाँ।
मैक्सिमम हो गया तो लिमिटिंग,
Limiting.
और जब हमारी
मैक्सिमम से ऊपर हो गई, मैक्सिमम से ऊपर हो गई काइनेटिक. लिमिटिंग से ऊपर हो गई काइनेटिक. ओके,
काइनेटिक. यस सर।
ठीक है. तो सबसे पहले
जो लिमिटिंग जो वैल्यू है वो काइनेटिक से थोड़ी
ज्यादा होगी.
सर ये पॉइंट
जो लिमिटिंग जो वैल्यू,
भाई लिमिटिंग की वैल्यू
लिमिटिंग की जो वैल्यू है
वो काइनेटिक से ज्यादा होगी बिकॉज
जी।
म्यू एस इज ग्रेटर देन म्यू के. ये देखो ना, ये काइनेटिक है
यस
और ये लिमिटिंग है.
जी सर।
So mu s is greater than mu k. So mu s n is
Yes,
greater
sir.
than mu k n.
यस सर।
Okay?
यस सर।
Okay. Good. So this is very important forces और ये आपको समझ में आना चाहिए. So now let's go for one final forces, that is pseudo force. Okay? Then कल हम लोग इसके ऊपर प्रॉब्लम करेंगे. ठीक है?
Sir, I have a very basic question. Can you talk about normal force that we have been using it regularly that I have forgotten the essence at all.
Normal force is the force which will act one body to the another body due to some applied forces. Okay?
Sir, we usually take it as opposite to the weight, right, sir?
That is opposite to the weight, obviously. Yes. So what is problem in this?
Okay.
Not only opposite to the weight, that is perpendicular to surface. Exactly not opposite. Okay.
Okay, sir.
So don't, if listen, if you are in this situation, okay, then normal force is like this, okay. But if you are in this situation, then normal force is like this. Your weight is this. Are you getting my point?
Yes, sir.
Okay, so you can just note down normal force is always perpendicular to surface.
Sir, it
Okay.
is to validate Newton's second law, right, sir?
Yes, it will validate Newton's second law.
Thank you, sir. Sorry, it's a very basic.
No, that's very important. You have to always give the direction. So just write down this point. Normal force is always perpendicular to surface. Nothing to do with the weight. Okay?
Okay, sir. Thank you, sir.
Okay.
Sir. Sir, we are doing this under the like US is greater than UK. So there is any reason behind it, or we are just like
no, this is just a observation.
That US is greater than UK.
Yes, this is just observation. I have told you now one experiment.
It is observation.
Yes, that is, and you may at the microscopic level you can derive it also, but I am not going into so deep of this. Can you please tell me that frictional force is which kind of force?
Non-conservative.
Oh, it's okay, good. But they are actually electromagnetic force. Okay.
Oh, okay, sir.
Okay, so when you have two surfaces there, and there is interaction at the microscopic level between these two surfaces, and then frictional force is going to generate. Okay.
Okay, sir.
And due to that particular fact,
this is an observation.
This is one type of observation that you have always a static friction is greater than limiting friction is greater than your kinetic friction. Okay. Not a static friction is greater than kinetic friction. Limiting friction is greater than kinetic friction. Okay.
Okay, sir. Yes, sir.
है ना, आप तो देखते होगे ना, कई बार अलमीरा पुश किया होगा, बेड पुश किया होगा, तो इनिशियली ज्यादा फोर्स लगाना पड़ता है. You will just push it, but it is not move. It will not move, but suddenly it is move, and you will smoothly move it. Isn't it?
Yes, sir.
So this is due to fact that static friction is coefficient of static friction is more than coefficient of kinetic friction. Okay. And this is just a measure, then this is just due to the relationship between two surfaces. Which type of surface you are working for? Isn't it?
Yes, sir.
Okay. And this is very important thing that these are basically electromagnetic force. Are you getting my point?
Sir, why electromagnetic force?
Because this force is generated due to interaction between at the microscopic level. These forces are generated due to interaction between the electrons between two surfaces.
Okay. Frictional force is actually
electromagnetic
interaction
force
between electrons.
Yes. If you will go for the microscopic and molecular level, then you can get this thing.
Okay, sir. So from microscopic level, mu s is greater than mu k proved. It can be proved.
It can be proved.
From microscopic level.
It can be. It may be. So, but in general, in general, we are doing the mechanics for the macroscopic level. Okay.
सर 12 को एक्सपेरिमेंट होता है इस पे.
ठीक है. We are doing it for the macroscopic level. है ना? But
Okay.
देखो, कोई भी मैक्रोस्कोपिक रिजल्ट जो है उसका कहीं ना कहीं तो माइक्रोस्कोपिक ही है. आर यू गेटिंग माय पॉइंट? बट ओवरऑल चीजों को हम देखने के लिए यहाँ पर कोएफिशिएंट ऑफ फ्रिक्शन का यूज कर लेते हैं. ठीक है.
Okay, sir.
Okay.
Sir, friction force arises due to relative motion between two surfaces.
Yes.
But still it not depends on the surface area.
That will depends on motion. That will depends on your applied force. That will depends on which type of nature of this particular thing, the surfaces. Area पर कुछ भी depend नहीं कर रहा है ना? The surface, nature of surface के ऊपर depend करेगा.
Okay, sir, and that information is under coefficient of friction.
Of coefficient of friction. Yes.
Okay, sir. Thank you.
Okay. So I think I should stop here, okay, because time is over, and we will take the thing in next class. Okay? कल most probably मैं शायद होगा तो 2 क्लास आज मुकद्दर सर का खत्म हो गया क्या क्लास?
Yes,
Yes, sir.
Okay.
Sir. For next students.
नेट स्टूडेंट के लिए खत्म
नेट स्टूडेंट के लिए खत्म हो गया. Okay, good. जैम स्टूडेंट का चलेगा है ना?
Yes, sir.
yes, sir.
Okay, okay. So I will talk Satish sir. Maybe tomorrow I will take 2 classes. Okay?
Sir,
Thank you,
this
sir.
topic
Thank you,
will
sir.
also come in mechanics and general properties module.
Yes, that is, listen, if you have mechanics, this is very bad thing about mechanics. Okay? If you have classical mechanics in your course, then from +2 level to master's level, anything can be asked. Are you getting my point?
Yes, sir.
This is very bad thing about mechanics, and you cannot claim, sir, why you have given this question.
Okay, sir.
Okay, so I have seen the trend from last 2 and 3 years, and so I introduced this thing to the net and GATE students also. Okay.
Yes, sir. So please kindly share the modules, sir. It's getting difficult.
So you haven't model?
No, sir. For
No, sir, we don't
HTML
have it.
batch, we
Yes,
haven't
sir.
got them the module.
मोशन का नहीं है, गूगल क्लासरूम पे भी नहीं है और वो इसके
Satish sir said he will share it by tomorrow,
Okay.
but I'm just asking you to share it as soon as possible.
It surely sent by tomorrow. Okay, don't worry.
Thank you, sir.
Surely.
Thank you, sir.
It's just remind me up to 1 o'clock. If up to 1 o'clock you are not getting this message, then please remind me. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Thank
Okay.
you, sir.
Thank you, sir.
And in the message, tag Satish sir also and tag me also. Okay.
Okay, sir. Thank you,
Okay.
sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you. Thank you.
Namaste.